This is how-to videos force example 2C, net force with acceleration. So we have someone in an elevator. Anytime you see something going on in an elevator, it means there's probably going to be some type of acceleration on the y-axis. But let's go ahead and point out the important information. 180 newtons, 310 newtons, and that looks to be about it. So if we draw a diagram of what's going on, we have the musical instrument having a weight, which we can write as W, or we can say Fg, and then we'd have a force normal. Okay, the normal force is also whatever the spring scale force is. So we can say it like that. We have a separate situation where the object is moving, and in that case, as it is accelerating upwards, the scale force is going to be larger than before. The gravitational force will still be the same size, but I'm going to go ahead and draw this to be larger. Okay, I will say that is, let's see, make that scale 2, and then we have scale 1. And we can list out our information. First, the scale force for 1 is going to be 180 newtons. Gravitational force is unknown. Mass is unknown. Acceleration. Well, in this case, in the case of the black, the acceleration would be 0. In the red, the scale force is going to be 310 newtons. And here, the acceleration is some unknown value. It is not 0, though. So before acceleration, we'd have our F equals ma, and we're talking about the y-axis. So sum of the forces on the y-axis equals mass times acceleration on the y-axis. We have the scale force, and I was calling that scale force 1, minus the gravitational force equals mass times acceleration. In this case, the object is not accelerating, so that means the scale force, force 1, equals the gravitational force. Or in other words, whatever the scale read in the first case, which is 180 newtons, that is what the actual gravitational force is. That's the weight. Now, I also know that gravitational force is equal to mg. Rearranging, solving for m, I have m is equal to Fg, gravitational force, divided by little g, the 9.8, and I can plug in my values, and I have 180 newtons divided by 9.8 meters per second squared. Tap, tap, and I get 18.4 kilograms as my mass. Okay, so that is one of the values I was looking for. Then I'm talking about once it is actually accelerating, and I have during acceleration, and I have the same equation as before. Force on the y equals mass times acceleration on the y. Scale force 2 minus gravitational force is equal to mass times acceleration on the y. Now you say, oh, I get to cancel everything out again. No. Okay, we know that the scale force is going to be 310 newtons. We knew that from over here, 310 newtons. And we know that the gravitational force was what we just solved for earlier. So that's going to be minus 180 newtons. And that equals the mass times the acceleration on the y-axis. Okay, so I can combine those together, and I get 310 minus 180 is 130 newtons, which that equals mass times acceleration. on the y. And then rearranging, solving for acceleration on the y, I have, just dividing through by mass, 130 newtons dividing through by the mass, which was from right there, 18.4 kilograms. If you tap that into your calculator, you get the acceleration on the y-axis as 7.07 meters per second squared. And that is the final answer.